is scene script. Have you ever wondered about the tiny particles that make up everything around us? Welcome to the world of atoms. You see, atoms are the fundamental building blocks of all matter. Yes, everything we see, touch, and interact with. From the air we breathe, the food we eat, to the stars in the distant galaxies, is made up of these minute particles called atoms. But what exactly is an atom? To put it simply, atoms are the smallest units of an element that still retain the properties of that element. It's like the alphabet to the language of the universe. Now let's delve a little deeper into the structure of an atom. Picture an atom as a miniature solar system. At the center, we have the nucleus, which is a cluster of protons and neutrons. Protons carry a positive charge, while neutrons are neutral, carrying no charge. Circling the nucleus in orbits or energy levels are tiny particles called electrons. These electrons carry a negative charge. Even though they are over 1,000 times lighter than protons and neutrons, they play a crucial role in the atom's behavior, especially when atoms interact with each other. The number of protons in an atom's nucleus defines the atom's identity, making it a specific element in the periodic table. For instance, if an atom has 1 proton, it's hydrogen. If it has 8, it's oxygen. Pretty neat, right? But here's a fun fact. Despite their importance, atoms are incredibly small. You'd need to line up millions of atoms end to end to make a line only 1 millimeter long. But don't let their size fool you. These tiny powerhouses form the basis of our existence and the universe as we know it. So atoms are the foundation of all matter, but how do they interact with each other? Atoms don't like to be alone. They bond with other atoms to form molecules. This is where chemical bonds come into play. Think of chemical bonds as the invisible threads that tie atoms together, creating the vast array of substances and materials we see around us every day. These are not just physical links, but complex interactions involving the swapping, sharing, or transferring of electrons, the subatomic particles that orbit the nucleus of an atom. Now, there are 2 main types of chemical bonds we need to focus on: ionic and covalent. Let's start with ionic bonds. Picture a generous atom, one that has an electron to spare, and a needy atom, one that could do with an extra electron. When the generous atom transfers its electron to the needy atom, an ionic bond forms. The giving atom becomes positively charged, and the receiving atom becomes negatively charged. These opposite charges attract each other, forming a bond. Table salt is a classic example of a compound formed by ionic bonds. Then we have covalent bonds. In this case, neither atom wants to give away an electron. Instead, they decide to share. By sharing 1 or more pairs of electrons, atoms can fill up their outermost electron shells and achieve stability. This sharing creates a strong covalent bond between the atoms. Water, with its 2 hydrogen atoms covalently bonded to an oxygen atom, is a familiar example of a covalent compound. You see, atoms are a bit like people. Some prefer to give, others to take, and some like to share. But unlike people, atoms don't have a choice. They follow the laws of quantum mechanics, which dictate their behavior. Chemical bonds are the glue that holds atoms together. But what happens when these bonds break or form? That's a story for another time. For now, just remember, without chemical bonds, life as we know it wouldn't exist. Chemical reactions are the drama of the atomic world. They occur when bonds break and new ones form. Let's take a moment to picture a bustling city. The buildings, the roads, the parks, everything has its place. Now imagine if suddenly some structures were demolished, others were built, and everything changed its location. This is what happens at the atomic level during a chemical reaction. In the microscopic world of atoms and molecules, chemical reactions are akin to construction and demolition projects. They involve breaking existing bonds between atoms and forming new ones, leading to the creation of different substances. Picture 2 atoms that are bonded together. When enough energy is supplied, this bond can break, freeing the atoms. This is similar to using a wrecking ball to demolish a building. The atoms, now free, can bond with other atoms, forming new substances. This is akin to using the debris from the demolished building to construct a new one. One thing to note is that just as a construction project requires a certain amount of energy, so does a chemical reaction. The energy required to break a bond is known as bond energy. On the other hand, energy is released when new bonds are formed. Now you might be wondering what triggers these reactions? Well, various factors can initiate a chemical reaction. These include heat, light, and even other chemical reactions. It's fascinating, isn't it? These processes are happening all around us all the time. Every breath you take, every leaf that photosynthesizes, every battery that powers a device, all these involve chemical reactions. Chemical reactions are the driving force behind many natural and man-made phenomena. But how can we quantify these reactions? Stay tuned to find out. To quantify chemical reactions, scientists use a unit called the mole. This concept is a cornerstone of chemistry, acting as a bridge between the atomic and macroscopic worlds. It's not about the small burrowing mammal, but a unit of measurement in chemistry. The mole is a way to express amounts of a chemical substance. It's like a baker's dozen, but instead of 12, it's Avogadro's number, a whopping 6.022 times 10 to the 23rd power. That's a lot of zeros. Avogadro's number is used to count entities at the atomic level, such as atoms, molecules, electrons, or other particles. Imagine having a mole of rice grains. It would be enough to cover the entire Earth. Now, when we talk about a mole in chemistry, we're usually referring to the number of atoms or molecules in a substance. It's a way to count atoms just like we count eggs, in dozens, or in this case, in moles. With the mole, we can count atoms just like we count eggs, in dozens, or in this case, in moles. So, we've taken a journey from the world of atoms to the concept of the mole. We began by exploring the fascinating realm of atoms, their structure, and how they form the building blocks of all matter. We then dived into the world of chemical bonds, understanding how atoms connect to form molecules. We saw how these bonds can break and form new ones in chemical reactions, leading to the creation of different substances. We finally introduced the mole concept, a fundamental tool in chemistry that helps us quantify these tiny particles. Chemistry is everywhere around us, and understanding its principles can help us see the world in a whole new light. Thanks for joining us on this journey through the principles of chemical science.